Welcome, everybody. I'm glad that you decided to pick this session called Is Your JVM App Flying Blind? Unmask Hidden Issues with Observability Superpowers. Who of you thinks that ChatGPT generated this abstract, this title? Okay, 2 people. Okay, you're also using ChatGPT from what I see. Who am I? My name is Marcin Grzejszczak, and I'm working at Spring. Currently at Broadcom. If you want to reach out to me by some sort of social media, I'm there at Mastodon. You can find my Twitter handle. Of course, I always have to tell this fabulous joke that if you're a foreigner, you can't really pronounce my Firestone last name, so you have to go to my blog, toomuchcoding.com, to find my Twitter handle over there, because it's a tongue twister. If you're a foreigner, don't try to pronounce my last name. You can injure yourself. So I don't have any slides, really. I have just code. And this HTML page that I've generated from ASCII Doctor. So let's start with a poor man's version poll. So who of you is actually using observability in production, whatever that means for you? Okay, quite a few people, very good. Who of you is using Spring Boot free? Okay, like half of the room. The rest is, of course, using Spring Boot 2 because there are no other frameworks out there. Who is using Micrometer? Oh, so more people are using Micrometer than Spring Boot free. That's really interesting. Prometheus? Okay. And last but not least, OpenTelemetry. Who's using OpenTelemetry? Okay, a couple of people. Okay, so more or less I know what the audience preferences are. Now, if we're talking about observability, for me, observability means how well we can understand the internals of a system based on its outputs. So that's going to be the, let's say, thesis that we have for today, because we're going to play with different types of outputs in order to understand our system. So for those who know me, it will be a very interesting thing to hear that at this presentation, I will be trying to deliver business value. Because I have been doing tools for the past decade or so. So whenever somebody hears me talking about business value, they are typically laughing. But today, I will be doing that because I will be a developer working on a system that tells us how to make tea. So the system looks like this. So we have a tea service, so the edge service, that delegates work to the tea leaf service that goes to a database, and the water service that also goes to the database. It's a very, very simple system of, let's call them microservices or whatever you want to call them. So I spent a lot of time on the UI. Like the UI is the heart of the system. It's reactive, it's responsive, it's Kubernetes, and it's AI, because these are the buzzwords of this year. So without any further ado, welcome. This is the T service application. It's reactive because it reacts to my clicking, as you can see. And it's responsive because if I click, it responds with with some table. So we can see that the best people we had on in our team worked on this for a very long time. And everything seems to be working fine. We can pick different types of water, and okay. I will refresh the browser. Okay. Internal server. I wonder what that means. Most likely, there's a server, and internally there was an error. So let's. Apparently, there's a problem. I can't refresh it enough for that to work. So let's try to figure out what's wrong. And for that, we're going to use observability. The tools that I'm going to be using are actually the Grafana stack, but whatever you have out there in your companies, it's as good as that. Like whatever you have, just use it. But let's try to have this go through this thought process of how we can use different types of outputs, different types of signals to understand what's going on in our system. So what I have here is the dashboard. Let me refresh it because it seems stuck. No, it should be fine. So what we have here is the dashboard dedicated to the T application. Over here we have the latency graph. In the middle, we have the throughput, where we have two types of, or let's say, codes. So we have the success and the error. So apparently, we do see some errors. Here we can see different types of T getting done. And here we have the histogram. So we have different buckets of the latency. So that's a heat map of latency. We can see that we are between 8 and 28 milliseconds in total. So I should have really looked into my email. I have an email here. Of course, I should have only one information here, that we have an error, but of course, as it happens with the demo gods, just before starting the demonstration, something went wrong with my laptop. Apparently, this is why we have more errors. But in general, so what I will do, and of course, you never do it in production, I will just remove the errors that I'm not interested in. So goodbye. Okay, yeah, now we have only one problem, right? Because I removed all the other alerts. So here we have high error rate. Apparently, now I know that indeed there is a problem. So what I can do is confirm that on the metrics side. Indeed, it's something is wrong. And what we were trying to do is to make a T using English breakfast. So that what I will do is I will jump from metrics to a different signal. So first signal we had our metrics. Now a different signal we're going to have are logs. How it's done, how the logs end up in different parts of the system, I'm going to tell you later. At this point, just think of the fact that all the logs from all the apps got pushed into a single location. Now I can do some search. So what I will do is I will search in one of the services, error logs. Actually, water service is not the good one. Come on. The TLeaf service, I guess. Level, error. And let's search for English breakfast. Breakfast. Run query. Okay, we can confirm that there are some errors popping in. Of course, with my setup, some logs are sampled, so not every logs are going in. But we can see that indeed there is a problem within this span of time that we have here. So like an hour or so, we had 146 errors related to English breakfast. So indeed, there seems to be a problem with English breakfast. So we jumped from metrics to logs. There was no correlation at this point between them. But now what we can do is grab one of the logs. We can see some logs related to English breakfast from that particular application. And what we can do is we can find its trace identifier. So a trace identifier, for those who don't know, is like a correlation ID. So for one business transaction, when various services will, send requests, process those requests, messages, etc., they all share the same identifier. So whenever a log happens that is related to that business processing, then they share that one identifier. And what we can do is we can jump to the trace view. So what we can see here is the trace view. So the generic view of how that particular request was processed over time by all the services that took part in that processing. So you can see that one of those English breakfast related requests was processed in like 17 milliseconds. First, we got the T service. Actually, we can even look at this in a service graph fashion. So if we scroll down, we can see that there was a user, then a request went to the T service, and we had water service and TLeaf service calling the databases, right? So we can see that. Now, if we go back, we can see that if you see this red exclamation mark, it means that there was an error. And the error happened on the TLeaf service side. So on the water service side, everything went fine. It was fast. But afterwards, there was a problem with the TLeaf service. So now, those little bars you can see are called spans. So that's pretty much a single operation. So if a request came in and it's being processed, that's a single operation. Then its child was, for example, going to the database and retrieving some data related to that database query. So the database query was, if we go to the attributes, we are selecting some data from the database with the parameters of English breakfast. And the result set, if we scroll down, we can see that the JDBC row count was 0. Aha. So we are asking for an English breakfast type of tea, but there were no results. So most likely this is why we got the problem. If we scroll up a little bit, we will see the error message, resource not found, tea leaf with name English breakfast. So that's a very good description of the problem. The resource was not found, it was not there in the database, right? So what we can do right now is, believe it or not, I have a special, I don't know how it happened. I have a special request that I can send to insert the missing type of tea. I wonder how it happened that I have it. So let's run it. We managed to do it, and now if we go back and look at the dashboard, very soon we should be able to see that the success rate goes to around 5 because we have 5 requests per second, and the server errors should go down, and we should also notice that I'm going to get an email finally that the problem is gone. Now I would ask you to just not look at what I'm doing. Goodbye. So let's wait for the email to come. In the meantime, I'm going to summarize this session, this part of this session. So what we've managed to do is to see that there was an error. We got the information that is related to English breakfast. We've managed in the logs to search for an example of such a situation, from which we've managed to go to tracing, where we did the analysis of what's going on. We understood that something is missing in the database. We updated the database, and now the problem is gone. And theoretically, I could finish the presentation, because if we go to the mail, we can see resolved, right? The high error rate is gone. We've managed to fix it. But what I'm not happy with is another error that happened here, which is high latency. So apparently somebody didn't want me to finish my presentation after around 10 minutes. So I have to continue, because unfortunately I fixed one thing and another thing broke. Who had such a situation in their company? Okay, don't raise your hand. Of course you did. So yeah, I mean, if we look over here in the middle, it's okay. Like the throughput is fine. We don't have any server errors because the English breakfast problem was fixed. But to the left, we do have a problem. We can see that the latency spiked. We used to have around 20 milliseconds. We can think that maybe Grafana is broken. Not really. If we scroll down, we can see that the heat maps, like the buckets, pushed up. Now we can see that the lowest bucket is around 80 to 112, and the highest is 157 to 100 something. Like it's a lot. Okay, so let's try to think about that one, because with bugs, like an exception was thrown, you could even theoretically SSH the machine, grep for logs, which you shouldn't do, obviously, but theoretically you can do that. You can find that particular log, great. But with latency, there's nothing in the logs, right? It's just slower. So how can we reason about that? If you, I don't know if you can properly see that, I guess the resolution is quite big. You can see little triangles over here, or if you scroll down, you can see those squares over here. So these are called exemplars. So what is an exemplar? When you have metrics, I'm not going to go into the details of the algorithm behind it, but the idea is that when you're capturing metrics, if there was a span there in the scope, if there was a span available, every now and then that span will be attached to a metric. So this is the correlation between metrics and tracing, right? So that way, what we can do is we can say, okay, let's take a trace from the history when everything was fine, and then let's try to take a trace right now when something is wrong. So what we can do is we can click at one of those, do query with tempo, and now let's pick a different one, for example, over here. Let's copy the trace ID, and let's split, and let's share. Boom. So now we are looking at two traces next to each other. Let's look at them like this. So the one to the left took around 25 milliseconds to complete. And everything is fine, by the way. I don't think I actually picked one for the English breakfast, but you can see that in the positive scenario, you would have in the span attributes JDBC row count equals 1. Now the same thing would be there for English breakfast. So what we are looking at here is that we have the water service at around 9 milliseconds, and here we have it around 150. So that's not good. And the tleaf service used to be 10, now it's 4. Okay, so let's say that the tleaf service is not a problem because it's more or less the same. It seems that the problem is the water service. So let's try to reason about that now. Okay. So now we have the full trace of the situation that we have currently. Now, what we managed to do is we managed to jump from metrics to tracing. Now, how can we jump from tracing to metrics? So the thing is, I'm going to show you that later in details, but underneath, we're using Micrometer Observability, which is one unique API to instrument once and have multiple benefits out of it. But the idea is that whatever signals, instrumentation types you have, metrics, tracing, whatever, they will share the same tags. And due to this, you can pick, for example, the first span. And for that span, you can say, hey, give me the throughput, right? And here we can see that the throughput went down, right? Because we have like increased latency. So the thing is, right now, we've managed to correlate traces with metrics, so vice versa, because we share the same tags. So we can prepare the query up front that the its properties, its parameters, its low cardinality keys will be fed from the given span. In this case, the T-service request span. So that's fantastic because we can look at things over time. But in this case, actually, we will do something else because we can see that the connection to the database appears to be the problem because it's increased in time drastically. So is it a singular thing, or actually can we confirm that this happens more in time? So what we can do is we can go to a different dashboard that we have, which is related strictly to JDBC and Hikari. And now over here we have the tleaf service. Now let's go to the water service. And let's increase this in time, not last 5 minutes, last 15 minutes. And what we can see, apparently, is that we have a spike, right? So we've managed to pinpoint the problem starting from metrics, picking 2 types of traces using exemplars, coming back from, like picking one from history, one from now, the current situation. We've managed to look at both of them at the same time. Then we reasoned about what we see. We saw that the problem lays with the database. Then we confirmed that using dedicated metrics for the database, that indeed there is a problem. Now, what can we do about this? How can we fix this one? First of all, what we could do, like a poor man's version of a fix, would be to introduce caching. So we would introduce caching, restart our apps, and then until the cache gets filled, it would be slower, and then the latency should be gone. For sure, what we should do is to try to understand what's going on. Maybe it's the problem with the network or with the database. So in both cases, most likely we should file a ticket somewhere or talk to some people. Or we should actually call make order that removes the artificial latency that I introduced by using toxiproxy that is in between my application and the database, which introduced 100 milliseconds of latency. So that's another way to fix the problem. So now we can look at that, wait a couple of minutes, and that way we will see that the the latency starts going down because of the artificial latency latency I have introduced. Okay, so let's wait. In the meantime that we wait for that to finish, let me summarize this part. Actually, I can even look at my notes if we went through all of the jumping. So what we've managed to do is we managed to jump from logs to metrics, actually metrics to logs through, or both ways through traces. There's no direct way of jumping between logs and metrics. You always go through traces. Now, logs and traces, they go together via the trace identifier, right? Because the trace identifier is the same for all the logs, because what's happening under the hood is that the tracing context gets propagated over the wire automatically. That's why all the applications share the same trace identifier. Traces and metrics, you can jump between them through tags, which I've shown you that when you have a span, you can, let's say, fill the query of for the metrics with tags that correspond to that particular span. That way you can go to metrics, and metrics to traces via exemplars. Why is it important? Because it's great if you have the so-called 3 pillars of observability, which is the metrics, traces, and logs. But it makes most sense if you can jump through them, if you can correlate them, because otherwise you're a little bit isolated. But if you can have the consistent story by going through those different dimensions, it's much easier for you to reason about different problems. And hopefully I was talking long enough, yes, for the latency to drop. And finally, I have the problem resolved. So we've managed to fix 2 things. One was a bug, an exception, and we reasoned why it happened, and the other was latency. So now let's look at how it actually works. So in this case, we have a Spring Boot application, but everything I've shown you today is irrelevant to the used framework. You can use whatever framework you have. And actually, Micrometer, that is the key thing under the hood, works with all the frameworks. So as with every Gradle build, I had to do a little bit of digging where to find the setup, because it can be everywhere. So what we have here is the following setup. So we have the Spring Boot Starter actuator, which brings in Micrometer. Micrometer is a library that allows you to do metrics and more, actually observability. We used to have this saying that it's like SLF4j but for metrics, but now we're saying that it's like SLF4j but for observability, and I'm going to explain why. Number 2, we have Micrometer Registry Prometheus. So we're using Prometheus under the hood, so this is why we have to add the Prometheus registry. That way, Spring Boot will automatically configure the proper servlet with the feed of Prometheus metrics that Prometheus can understand and scrape. Speaking of which, how does scraping work? If we go over here, we are actually using Eureka for service discovery. So what happens is Prometheus is going to Eureka in order to find all the instances that they can scrape. So you don't have to put it like fixed addresses of the instances. Now, due to the fact that we have, where is it? Oh, it's in a different service. Let's go to the water service now. Now, what we have here is, due to the fact that we have this dependency, we have JDBC instrumentation using Micrometer. So this is why we could have seen all the queries and its parameters, and we could pinpoint the issues related to data sources. Now, for tracing, we're using Micrometer tracing. Who of you has ever used Spring Cloud Sleuth? Okay, a couple of people. So I was the person behind the project, and the project is now feature complete. So we have never designed this to work with Spring Boot 3, and that's because what we did is we copied over the whole code of Spring Cloud Sleuth to Micrometer tracing, which is essentially literally a copy with some bugs fixed. Because Spring Cloud Sleuth was a library dedicated for distributed tracing, but it was Spring Cloud related. And there's quite a few of you that are not using Spring Cloud and want to have tracing, right? So what we did, we ported it over without any Spring or Cloud specific bits. Now, neither Spring Cloud Sleuth nor micrometer tracing were ever designed to actually handle the lifecycle of a span. These are what traces are for, and we support two. One is Brave, and the other is OpenTelemetry. And there were some people of you that actually used OpenTelemetry directly, so you can use our stuff with OpenTelemetry. That's like a no-brainer. Now, if you want to send the span somewhere, you have to, convert them into some format and send them over the wire. What we're doing is we're using the Zipkin reporter Brave. So for Brave, we are sending that in a Zipkin format. Zipkin is a server used to visualize latency and help you troubleshoot latency problems. We use today a tool called Tempo, but Tempo understands spans in a Zipkin format. So that's pretty much it as far as the setup is concerned. Now let's look at a little bit of code, because you can say, okay, how does it all work? How on earth do we have metrics and spans and everything, let's say, coming out of the box, assuming that I didn't write any code, which I didn't. So Spring Boot, Spring, and all the Spring projects, and quite a few projects out there are already aware of micrometer observation. So and often was the case that I did it personally, but or part of my team did that. But often these were the external projects that actually instrumented themselves using our API. Now let's look at an example of how actually instrumentation would have to look and why the observation API helps us do it. So let's say that we have a water controller that is a typical MVC controller. And we have an endpoint find by size that takes in the water fetcher interface and calls find by size. Now, what is that? Water fetcher is just an interface, nothing special. It takes in the size and the type of string and returns an optional of water. Simple stuff. Now, what if we wanted to instrument that manually? So first of all, we would have to, for example, create a tracing implementation. So water service tracing implements water fetcher. It will have to be a proxy pattern. So we have a delegate, like a function to which we delegate, and then we have to manually instrument. So we create a span, we give it a name, we stop Gradle, we give it a tag, we start the span, we open the scope, meaning we put it in thread local. That way, when we have a log, the trace identifier will be there in the logs. Then we call the actual code. Now we can say that log is actually a different signal, so maybe that should be put in a separate class. Most likely you're right, but that way we would have 3 classes to write, and I don't have that much time. So here we're actually calling the code, and then if there was an exception, we put an error, and finally we have to stop the span. Okay, so that's a lot of code. Then let's say we would do metrics, so we would create a timer. Now, first we would have to have tracing, because if we have a span in scope and there is a timer, we can have an exemplar. So again, we have a meter registry, we have a delegate, we start the timer, we call the delegate, and in the meantime, we record the time. Okay. Now we have to glue the whole thing. So, and you would have to do it every single time. So first of all, we create the tracing, to which the delegate is metrics, to which the delegate is the water repository. And then we call find by size, and that works. And now imagine you want to do it in your business code every single time where you want to instrument something useful. So that looks like pure hell. And now if you want to change, for example, the tags or the name of the span, you would have to change the instrumentation code, because this is the instrumentation code, right? So that's highly unfortunate. So what can we do? We believe that you can use one API to do that. So let's start with that you could just have an aspect where you do add observed, and you give it a name, which would end up as a metric name, a contextual name, which would end up as a span name, and some low cardinality key values. What is this thing cardinality? So cardinality means that the value can differ a lot. So low cardinality doesn't differ much. High cardinality differs a lot. Why is it important? Because if you have high cardinality values and you put them in a database, you can blow up the database. So this is why you should have this differentiation. But you can say, okay, aspect, wise guy, like you can hide all the complexity inside the aspect, so we can see it. So this is not special at all. And you're right. So let's look at how you would do it manually. So you create an observation that has a name, contextual name, some key values. You put it in scope. You call the actual code. If there was an error, you mark it an error, and when there's a stop, you mark it a stop. So now you can say, okay, still a lot of code, and it looks very similar to tracing. Kind of does, but there's nothing tracing related here, right? And if you say, okay, that's a lot of code, no problem, you're right. We can use dedicated methods for that. Do observe. I want to observe this, right? So in fact, when you look at this right now, that looks much nicer. Okay, but where is this complexity? Where actually do the tracing and metrics happen? So for that, we have to answer that question, we have to introduce two concepts. One is observation handler, the other observation context. So when we have an observation, there are certain events that happen. If we scroll back, go back to this previous case. We have a start event, we have an open scope event, we have the close scope event over here. We have an error and stop, for example, right? So there's a couple of events. So we can do is we can create an observation handler that reacts to events. So on start, for example, I want to log out stuff. On error, log something else, etc., etc. So with the observation handlers, we are separating the actual features of the observability from the actual instrumentation. It's over here that, I mean, we are providing, let's say, some default handlers, such as a tracing handler or a metrics handler. But if you, for example, would like to, in your company, start doing an additional thing in every place or limited places within your system, you could create a handler without looking actually at where those places are, right? So you don't have to change any instrumentation code. You just add behavior. So we believe that actually adding behavior to your observability is a configuration thing. So this is a handler. Now, because if you, for example, created a span here on start, but you would like to, for example, reuse it on error, you would have to use a thread local, theoretically, to capture the state and then retrieve it, which we don't like thread locals. So what we can do is we're giving you a mutable bag, which is called a context. And that's the second thing. So a context essentially is extending our thing, but it's essentially a map to which you can put quite a few things yourself. Okay, but you can still say that if we go to the second, let's say type of service that uses the context, that nothing changed a lot, because now we have a water fetcher context, fair enough, we are passing it, but we have a lot of stuff here hard-coded. So if in the instrumentation code I want to change the cardinality key values, the low and high, I still have to go to the instrumentation code. And you're right. So how about we try to separate the instrumentation completely from the naming conventions? And that's something which is called an observation convention. So if we look at the observation convention, it tells us that we have, tell us what your low cardinality key values are, the high ones, what is the name, what kind of context it supports, and what's the contextual name. So for the water observation convention, we have the one that supports the water fetcher context. And now we can have a default one that says, by default, all the metrics and traces should have the environment key value with the value development, for example. Or all the water observations should have the high cardinality key value water size with the given size of the water. That's high cardinality because the sizes can vary a lot, right? What should be the name? Water-free, find by size, and contextual name depends on the context. Because, for example, for the spans, the name can change because you have HTTP post, or HTTP get, or HTTP whatever. So that depends on the context. So now, if we look at the code, what we do is, we have the context, we create an observation, how I'm going to show you in a second, and we call observe. That's it. So no naming. Now, who of you loves writing docs? Okay, 3 people. 4. That's a lot. I was expecting nobody. So I love reading docs when they're well written. I am not an expert in writing good docs. But what I believe in is that the docs can be written by themselves. So this is why in Spring we have, for example, Spring REST docs, where you have the MVC-based tests, basing on which you can write your docs. We also believe that if you create your observations in a given way as a blueprint, we can do something nice about this. So if we go to the water observation documentation, if you create them in a special way, that it's an enum that implements an interface, and you tell us that there's one observation, the default convention of which is this one, that the low cardinalities are such, that the high cardinalities are such, etc., etc. Then, if you run a special task that we provide, if you scroll down, micrometer docs generator, I wonder what that does. Then, we will generate ASCII doctor version of your docs, of the docs of the observability. So what we're doing is we're scanning your sources for those specially designed classes, and then we can say that these are the observation conventions that you have, these are the metrics that you have, and for example, these are spans that you have. And here you have all the names. These are the Java docs that you provided. And that way you can attach this to your documentation and never again have to write docs by yourself. And actually, we eat our own dog food, and quite a few Spring teams are actually already using this. And they, whenever they change their observations, automatically their docs get updated. Okay, so we have that one. Now, the fun part starts. So what else can we do with observation handlers? Because I believe that there's a lot of power that you can have there and do quite a few things. So either by using observation handler or a different type of a solution, which is an observation filter, doesn't matter. You can double check, for example, that in your tags, there are no passwords. So you can introduce security concepts. Because accidentally somebody added the username or user password, which is something you should not, for example, push to a third-party metrics aggregating solution, because it's, for example, against the law. So you can create such, let's say, components that would remove those things. Or you can build some things on top of that, right? And now, who of you knows how to read music notes? Okay, there's quite a few people. So now I'm going to show you something. But if you know what that is, like, don't spoil the surprise. I'm going to turn on the music. Because what we said, let me actually show you that again. We mentioned one thing, that observability, how well we can understand the internals of a system based on its outputs. So we mentioned a couple of outputs, but outputs is like quite arbitrary. So what I'm going to do is I will restart my apps, come on, and add a small profile to them. Now, I'm going to show you that in a second. And first of all, I'm going to show you this. So we have a different handler, which is called an SEC observation handler. SEC is like server send events. So what it does, let's start over here. So it reacts to contexts of type server request, observation context. So whenever a request comes in, this handler kicks in. Okay. Let it run in the meantime. So what we're doing here is whenever a request comes in, we're storing some information about the request. And now we have a SSC controller that will take those asynchronously, those stored information and put them on the website. It looks like this. Let me actually refresh this. So what you see here is that the green card is actually a successful request with its latency. And now you can see some sound. And now for those who know music, can somebody try to explain, or do they know, raise your hand, if you can read this melody and tell me what the song is. Let's give it like 10 seconds. Yes! So that's Never Gonna Give You Up, sang by our app by doing observability and taking in the requests and treating those requests as, let's say, inputs. And the output, in our case, is music. I didn't think of that. It's my friend Jonathan Ivanov who actually even created the whole MIDI part of this. And a different way that he created in the code is that whenever there is a bad request, there is a cymbal crash. And whenever there's like everything else is fine, there's a piano playing. It's a little bit of a joke, but actually not really, because it's all about how you treat the output. If actually you would like a horn to be played whenever there's something wrong in your system, you can do it like that. Okay, so I think that's it from my side. Let me quickly summarize what and maybe stop the music because it annoys me. So what we managed to do today is we analyzed our system in terms of two things. One is the latency. The other is issues related to some code problems. We've managed to understand what the three pillars of observability are, so logs, tracing, and metrics. We've managed to jump between the three using different things like exemplars, tags, trace identifiers. And we've managed to fix the problems. And then we've managed to look into what micrometer observability is. We understood that it's inbuilt in quite a few projects out there, not only Spring. I've managed to present how the observation handler works, that you can introduce your own handlers, your own solutions that will introduce new behavior to your system without actually modifying any instrumentation code. What is also important is that, for example, in many of your companies, you have your own conventions of, like naming conventions. Over the course of years, they were, let's say, created. So, for example, metrics for requests are called like this. The metrics for, spans for requests are called like that. And suddenly, for example, you want to standardize. One of the standards, the naming standards out there is the semantic conventions from OpenTelemetry, for example. And now imagine that you want to go that route. So you'd have to search all the places in your instrumentation code to change all the names. With what we presented, observation conventions, it's a configuration problem, right? You can gradually migrate, for example, by adding beans or like modifying your configuration. So I can show one more thing, the last one. So whenever I can show it wherever, for example, here. So if you're not using a Spring, in general, whenever you have an observation registry, you can do observation registry config, and you add a handler. That's it. And now, if you have a new behavior that you want to add, you add it here. For naming conventions, you would do observation convention, and here, for example, you can globally change it, right? Because you can pinpoint the change. For example, you can add the convention or modify the convention that is there in Spring Boot's request processing, but you can also change it globally. Okay, so I guess that's it from my side. We can look at the cards popping up. And in the meantime, I will check, because we have 5 minutes, I will check the questions at Slido. Okay, there are 4 questions. Room 10. How much performance does tracing for spans have? Any tips for keeping performance impact low? So it all depends on how the instrumentation is done, and which tracer are you using? Because in terms of, let's say, micrometer tracing, we are just an abstraction layer that delegates work to, let's say, other components. So either the OpenTelemetry bridge or the Brave bridge. The thing is, that those tracers differ. They are it was the last time I checked it, Brave Bridge was faster, but I checked it like half a year ago, so I didn't check it quite recently. Maybe OpenTelemetry made some improvement. The impact is depending on the also what kind of programming are you using, because if you're using reactive programming, the impact is going to be significant. Because I mean, even though we have vastly improved it, because now Project Reactor natively understands micrometer and micrometer context propagation. We created a separate project just for propagating context. Still, stuff has to be put in thread local. So Reactor plus putting stuff in thread local equals latency. You have to calculate how it's there in your case, but normally it's neglectable. In case of Reactor, it's not that neglectable. Okay, so okay, answered that one. Wait a second. Spring Boot version 3 is a must. Will it work with 2.x? How can I do it? Wait, popular. Okay. So Spring Boot version 3 is a must to use micrometer observations, because Spring internally Spring 6 and Spring Boot 3 understands micrometer observation and uses it throughout the system. So you can't, I mean, with Spring Boot 2, you'd have to use Spring Cloud Sleuth still. There's no way to make Spring Boot 2 be aware of micrometer observation. I mean, you can set everything up yourself, but there's no instrumentation of Spring itself that, that understands micrometer observation. Can we find the code you presented online? Of course you can. GitHub, Jonathan Ivanov, T-House. Jonathan-Ivanov/T-House. That's the, and I have a branch called 2024-Marcin, I think. But in general, that's the repo that contains the code. Oh man, the questions are piling up. I'm too slow. Wait, now I have only 3? Wait a second, I will refresh. As usual. You did what? How do I archive? No, but there are 3 left. I don't know what happened. What if you want to... Okay, let's start from the beginning. Does it also require any specific logger configuration to make sure it will work with Loki and keys are properly indexed? Thank you, I've forgotten to show that. So I've shown how traces are sent, spans. I showed how metrics are retrieved, Prometheus. Loki. Logback Spring. We have a log key appender. Let's look at the build. Low key logback appender. That's what we have. And what we're doing is over here, we are sending it to Loki. And we have a special pattern, and that's it. Pretty much that's it. You don't need anything else. The key thing over here is that org name, app name, host name are taken from variables to the top, I think. Org name, app name, they are here. But for example, trace ID is taken from MDC, so for local. And the default one is 000, which is the invalid one for OpenTelemetry. So thanks for reminding me about that one. Oh man, client pays for every megabytes of logs. Are there any good practices or prepared configs options to handle it? Turn off log from data access object layer without rebuilding apps, for example. I'm not an expert in like optimizations of logs, but actually in one of my previous jobs, what happened was for some reason, our developers didn't understand that debug is actually really debug. And not everything should be debug. So we like our Elasticsearch instances were going nuts. So we bumped it to info, and the problem was gone. And we told them, like, if you really need logs, think them through and add them as info, but just don't log everything out and store it, because that costs money. So I don't have any like special fantastic advice how to solve this problem. I think it's a business problem, and you should talk to your developers that they understand that their decisions cost money. I had once a presentation about this because typically developers are like, okay, let's use the latest and greatest, let's migrate this to that, but they never think of, or rarely think of the cost of their decisions, right? So the same thing about logs. So maybe it's time to talk to your devs to be more reasonable about that. We're almost, well, we're out of time, but I have 3 questions left. What if you want to use Grafana stack but avoid logs in Loki? Obviously, you can use elk stack. There are tons of things you can use. I just use Loki because it works together. But as far as I know, Grafana allows you to hook in different things. I don't know if you can embed that view in Grafana. I have no idea. I'm not a Grafana expert. But like whatever tooling you have, just go ahead and use it. But be sure or try to do your best to be able to jump between those tools, right? Trace sampling rate and sampling decision impacts performance, right? Thank you very much. So sampling, I didn't talk about that because it's a little bit more in the details of tracing. So imagine that you have hundreds and thousands of requests that produce millions of spans that you would be shipping to your tracing backend. You can blow up the tracing backend. So what we have is sampling. So by default, 10% of the traces are actually shipped. The trace ID is propagated always, but 10% are actually shipped. So that doesn't impact performance a lot because it's just a sampling decision to take. It's a minimum impact, but the impact is on your systems, right? Because either, for example, you store like a 10% out of millions or millions, right? Can we set a percentage of samples over specific endpoints error code groups? This is called adaptive sampling. We don't have it out of the box yet, but as far as I remember, out of the box being inside the abstraction of micrometer tracing, but as far as I remember, OpenTelemetry has it, so you could configure it directly on the OpenTelemetry side, on the configuration that, for example, Spring Boot provides, or if you're not using Spring Boot, you could create the micrometer, configure the micrometer observation, the micrometer OpenTelemetry bridge in such a way that it uses a tracer that is configured to be adaptively sampled, right? So the problem is pushed down to the OpenTelemetry tracer. And that's it. So that's it. If you have any questions, you can come over, and thank you very much.